going to talk about where most of the energy on our planet comes from. And ultimately, the primary source of energy on our planet is the sun. It actually drives and has driven even energy sources you might not normally think of. For example, the sun is ultimately responsible for producing fossil fuels. It's actually not producing water itself, but it produces it helps drive the water cycle, and then we can create dams that harness that. And it even creates and is responsible for creating wind power. Now, there are some things that the sun, there are a couple renewable energy sources the sun's not directly responsible for. For example, geothermal energy, where energy from deep beneath the Earth's surface is harnessed. Also, if you watched maybe a video in my class on how we can actually use tides to generate energy, even though that's in water form, that's correct. The tides, though, are not directly driven by the sun. They're driven by the gravitational pull of the moon. And actually, the sun does help with that gravitation as well. So otherwise, we're going to talk about three main ways the sun helps us produce energy. And those three are on the screen: fossil fuels, water, and wind. And I'll take them each individually. A lot of our energy that we get from falling water is actually also, believe it or not, driven by the sun, and that's through a process known as the water cycle. And so just a quick review of the water cycle. You probably learned this in probably 6th grade or even earlier, but water is heated by the sun, and that causes it to turn into a gas, so it moves up into the air in the gas form. That can happen from the ocean, lakes. It can even happen from plants like trees. Water can evaporate from them. That's called transpiration. And it goes up, and as it gets colder, that water turns back into a liquid. And actually, there's little dust particles in the clouds, or in the atmosphere. And if water condenses on those or turns back into a liquid, that's what forms a cloud. So it turns back into a liquid, turns into a cloud, and eventually, if you get enough water accumulated up there, you'll start to experience rain down below. And that happens, those rains or precipitates down, and that could be happening anywhere along here, really. And what will happen is you'll form rivers. Now, what we do as people, and I think I'll zoom in here on my river. Oops. Zoom in on my river. What we do is we occasionally build a dam, and it's just a wall that's going to stop the water. And what happens when we build the dam is the water over on this side will accumulate and form a reservoir. So you get a reservoir over here. And then this water is higher over here, so we will control it through the dam and let it fall down. And we use that falling water that's now kinetic energy to turn a wheel. And just like all the other energy forms, that's basically a turbine, and that turning wheel produces electricity that we can use. So the water cycle is basically what drives the ability to be able to do that. So I thought I'd put that in there as an example of how we use the sun's energy to drive what we would use then to make a dam and falling water for the water cycle for energy. Okay, this is a discussion about how fossil fuels, the energy in fossil fuels is actually energy that was originally in the sun, and a brief description of how fossil fuels were made. So imagine land here, and we have green plants, and the sun's energy through a process known as photosynthesis, the energy from the sun ends up getting stored in plants in the form of sugars. And then what happens is animals come along Here's my animal. eats the plant, and then the energy stored in the plant gets now stored in the animal, and there can be animals that eat animals and so on, but the entire energy source originally came from the sun. Well, what will happen is when those animals die, sometimes other organisms will eat them, and that's what typically happens, and that energy will be passed on to other organisms. But if they're buried in the right way, so if they die and they get buried underneath of the earth, what can happen is those organisms can, let me draw them here first. So here was my tree. I'll put it sideways. And my animal. There's my animal. If they get buried in the right way and get put underneath the earth, this is layers of the earth, and through heat and pressure and thousands of years, those organisms can change. And as they change, that's my blue representing change, or I'll put a little change there. As they change, they can become known as fossil fuels, which is basically stored energy from dead animal and plant material. So fossil fuels. And then we can pump those out of the ground in the terms of petroleum, coal, natural gas, and use those energies for usually for turning a turbine or moving a car forward. So those would be non-renewable energy sources. And again, they mostly, the original energy stored in these animals originally came from the sun. Okay, we're going to talk about what creates wind. Wind is really created by a difference in temperature, which creates a difference in pressure, and that difference in pressure is what creates wind. And most of the time, the difference in temperature is initially caused by the sun, okay? And the kind of things the sun is hitting, like ocean or land. So ocean water, or water in general, does not heat up or cool down very much. In fact, it's about 50 degrees Fahrenheit at the Oregon coast almost all the time. It doesn't matter the time of day or the year. Whereas the land, if you live in Medford, Oregon, you know that the land changes temperature a lot. And that has an effect of the air over it. So ocean water, for example, might cause the air above the ocean to be colder also in that 50-degree range, and that's going to cause the air particles to be relatively close together. Okay, they're compact, they're close together. And the warm air causes the particles to move faster, and they actually spread out. So they're not as compact. Now imagine you're in the air. So here you are, or here you are. Which side is going to have more particles hitting you at any given time? Yeah, if you're over the ocean air, you're going to have more particles hitting you. And so what happens is you end up with a greater pressure because there's more particles hitting you here. And you end up with a lower pressure over here. And air, like all things, will move from its highest pressure to its low pressure. And those air particles start to move this direction. Okay? And that's really what causes surface winds, or winds near the land, or near the surface of the water and surface of the land. And what's interestingly enough is these particles, since they got spread out over here, they're actually less dense, and less dense things rise. That's why hot air rises. So actually these particles start moving up here too. And because the particles over here are actually more dense, it's really cold up here, it causes them to sink. And you actually end up getting a current going up here too, in the opposite direction. So you actually end up with winds going the opposite way in the upper atmosphere as they do in the lower atmosphere. And you get a cycling of air particles, which we know as wind. And we call this, by the way, a convection current. Now, at night, the ocean stays pretty much the same temperature. But the land, imagine Medford, Oregon on a cold spring night or cold fall night, could even get really cold. It might even get below 30 degrees here at night. And we end up with the exact reversal. You end up with air particles spread further apart over by the ocean and really close together over here, and you end up with a high pressure over here and a low pressure over here, and the wind blows the opposite direction. Now in either scenario here, we like to tap into that, so we can build things like windmills in correct locations to generate energy, and that just works by turning a turbine, which we've talked about in here, which will then generate electricity that we can use. So I hope you understand how the sun changes the temperature of our planet. Those temperatures change pressures, and it's the difference in pressure that causes the wind.